In this video, we will talk about complex numbers. A complex number is a number which will generally denote by the letter Z, is of the form a plus bi, where both a and b are real numbers. So if you write a number a plus bi, where you know for a fact that both a and b are real numbers, then this number is called a complex number. In this video, our intention is to study the property of complex numbers, such as how to add two complex numbers, subtract one complex number from the other, how to take powers of complex number, roots of complex numbers, divide a complex number by one other complex number, multiply two complex numbers, etc. But one very important and nice thing we are going to do with our complex numbers, we are going to understand them in terms of the trigonometric ratio sine and cosine. So a complex number z equal to a plus bi has the polar form or the trigonometric form as z equal to r times cosine theta plus I sine theta, where I is the square root of -1. And r is called the radius of the complex number, and that is also called the modulus of a complex number or absolute value of z. So r is absolute value of z, which is modulus of the complex number. And it is given by the square root of the square of a plus the square of b. So you can think of any complex number as a point in the polar form on the two-dimensional plane, where a stands for the x coordinate and b stands for the y coordinate of the point. And tangent theta, as usual, is b over a. The number r is the modulus of z, and theta is an argument of z. Conjugate of z is given by z bar, and that is a minus bi. So we can easily verify that 1 over z is modulus as square of z dividing the conjugate of z. So let's talk about all these things and try to understand them a little better and verify some of these properties on our own. So as I said, a complex number is denoted by z, and it is of the form a plus bi, where both a and b are real numbers. So for example, you can simply think about a complex number as a point on the two-dimensional plane, and you can give it the polar form r comma theta, or you can call it x comma y. In either way, we know the interrelation between x, y, and r theta. So r is absolute value of z, which is called the modulus of the complex number, and that is square root of x squared plus y squared. So if your complex number is a plus bi, then you can think of this as the point a comma b, and you can also think of that as r comma theta, and the interrelationship will be given by r equal to absolute value of z or modulus of z or radius of the complex number, which is given by the positive square root of the square of the x coordinate plus the square of the y coordinate. And tangent of theta, as usual, that we have done in polar coordinate, is given by b over a. The conjugate of a complex number is simply changing the sign between the real component of the complex number and the complex component of the complex number. So if the complex number is a plus bi, I make it minus and call it a minus bi. And it is denoted by z bar. So if someone asks us what is 1 over z, I can think of that as z bar over z times z bar. So what I have done in this, I have multiplied the conjugate of the complex number z on both top and bottom. Now think about what happens. Say z, the complex number is a plus bi, so on top you have a minus bi, on the bottom you have z, so a plus bi, and the conjugate is multiplied, so a minus bi. So I'm going to work it out a little bit. So on the top I am still a minus bi, on the bottom, if I FOIL, I get a squared minus abi plus abi, and I get minus b squared I squared. But remember, I is square root of -1. So when I do I squared, I get -1. So this is going to be a minus bi over a squared. The two intermediate terms, they will cancel each other because they are the same term and negative to each other. And then, as we have talked about, you're going to get minus b squared times I squared. And I squared is -1. So I get to say that this is equal to a minus bi on the top. On the bottom, you have a squared plus b squared, or I can write one more step for us to understand. It is minus b squared times -1. So a minus bi over a squared plus b squared. Now remember, the modulus of the complex number r is square root of a squared plus b squared. So a squared plus b squared is r squared. So on the bottom I get r squared, on the top it is z bar. So that's the conversion or the process of dividing by a complex number by another complex number. So while dividing a complex number by another complex number, you will look at the complex number that is in the denominator, take the conjugate of that complex number and multiply the conjugate of the complex number in the denominator on both top and bottom, and then simplify. That will be our usual process of dividing a complex number by another complex number. So I can also say that this is equal to z bar using the absolute value of z notation. It is z bar over absolute value of z squared. So this is precisely what we have seen so far. We'll go back. There are two other very important rules associating the degrees of complex number or the powers of complex number and about the multiplication and subtraction, division of complex numbers. So if there are two complex numbers z1 in the polar form as r1 cosine theta 1 plus I sine theta 1 and r2 as cosine theta 2 plus I sine theta 2, and I multiply them, then it is essentially multiplying the radii together, r1 and r2, and adding the argument of either of these complex numbers, theta 1 and theta 2, and taking the cosine of that and sine of that and writing it in the complex form. Whereas while dividing, I'm supposed to subtract the argument and divide the complex number's radius on the top by the complex number's radius on the bottom, provided the complex number on the bottom is not equal to 0. So again, I would like this opportunity to explain what we are doing in the multiplication and division of two complex numbers. So let's think about the formulas, and we're going to kind of establish these formulas ourselves using our trigonometric skills. So as we started by saying, z1 is my first complex number, and z1 in our situation is given by r1 cosine theta 1 plus I sine theta 1. z2, the other complex number, is given by r2 cosine theta 2 plus I sine theta 2. So both complex numbers are written in the polar form. When I multiply them, of course I multiply r1 with r2. Also, the trigonometric parts are going to get multiplied with each other, and essentially I'm going to FOIL. So I will get cosine theta 1 cosine theta 2, and if you want to know how we are getting these products, you can do a scheme diagram. So for example, I have multiplied these two together. Now it's time to multiply these two together. So I will get I times sine theta 2 cosine theta 1. Then I can go ahead and multiply this to that, and I will get plus I times sine theta 1 cosine theta 2, and finally there will be one other multiplication, and I will get I squared sine theta 1 sine theta 2. And then we're going to look at these a little closer. So first and foremost, recall you have cosine theta 1, cosine theta 2, and I squared is negative 1. So if I change this I squared by negative 1, I get minus sine theta 1, sine theta 2. The other two terms in blue, both of them have I in common, so I will factor that out. And I will get sine theta 2 cosine theta 1 plus, you can write it as cosine theta 2 sine theta 1. And that reminds me about the formula of adding two angles. So it is the sum formula for cosine first and then the sum formula for sine. So I will go ahead and say that this is R1, R2. As I said, cosine of theta 1 plus theta 2. And then I have plus I sine theta 1 plus theta 2. And that kind of answers why the formula of product looked like how it looked like. Okay, so we can do the similar thing with the division and hence keep using this formula. So now I'm going to do Z1 over Z2. So remember the formula in your head and try to see what I'm doing. So R1 cosine theta 1 plus I sine theta 1 is on the top. Bottom is R2 cosine theta 2 plus I sine theta 2. And I already have told you what you need to do in order to do complex division. Look at the complex number on the bottom. Think about its conjugate and multiply the conjugate on both top and bottom. So I'm going to multiply cosine theta 2 minus I sine theta 2. That's the conjugate of the complex number on the bottom. And cosine theta 2 minus I sine theta 2. And then it's time to simplify what we have done. And I'm going to do it in a brute way of distributing everything. So R1 over R2, these are the radius parts, so I can write it separately. What else I have? On the top I have cosine theta 1 cosine theta 2 plus I sine theta 1 cosine theta 2 minus I cosine theta 1 sine theta 2, and then you have minus I squared sine theta 1 sine theta 2. And every time I write this term, I remind you that I squared is negative 1, so that we get easier manipulation. Whereas at the bottom, we're going to have cosine square theta 2 plus I sine theta 2 cosine theta 2 minus I sine theta 2 cosine theta 2 minus I square sine square theta 2. Use the value of I square equal to negative 1 now on both top and bottom. So you will get R1 R2 over R2 cosine theta 1 cosine theta 2. I'm going to replace the I squared by negative 1. So negative times negative will be a positive, and I will get sine theta 1 sine theta 2. And then from the rest of the two terms, I factor out the I, and I get sine theta 2 cosine theta 2 minus cosine theta 1 sine theta 2. And both of these on the top are the subtraction formula or the difference formula, first for cosine and then for sine. Okay, so I should have said sine theta 1 here, so let me change it. Should be sine theta 1 cosine theta 2. Okay, see on the bottom you have cosine square theta 2 plus I squared is negative 1, so minus times minus is a plus, sine square theta 2. And the other two terms, you have cancelled them with each other because they're the same term, negative of each other in sine. Which is really good news for us, because now we are going to go ahead and say that this is equal to R1 over R2. And then on the top you have cosine theta 1 theta 2 plus sine theta 1 theta 2. As I said, this is cosine theta 1 minus theta 2, difference of cosine angles. And then plus I, this is difference of sine angles, so sine theta 1 minus theta 2. And on the bottom you have 1, that's a Pythagorean identity, and we're done. So that's the formula for division. The final pair of formula are going to be the formula for taking the power of a complex number of the form r cosine theta plus I sine theta. And if I take the positive integer power, say n, of this complex number, then that looks like r to the power n. So the modulus of the complex number, or radius of the complex number, take the nth power of that. And the argument portion, you write it as cosine n times the argument of the original complex number plus I times sine n times the argument of the original complex number. Now this, I will not be able to show you how to establish, but we can prove this thing by a process called mathematical induction. And with a little bit of mathematical maturity, we can actually establish this formula. Likewise, we have established the formula for the product of complex numbers. Similarly, if z equal to r cosine theta plus I sine theta is a complex number and n is a positive integer, then the nth root of the complex number are given by r to the power 1 over n. So take the nth root of the modulus, and I would say the positive root of the modulus r, and for the argument, write it as cosine of argument of the original complex number theta plus 2k pi over n plus I sine theta plus 2k pi over n, where k runs from 0 to n minus 1. So these are a little bit of critical formulas for us to remember, but when we practice more and more problem, these formulas becomes way easier to understand and remember. So at this point, I'm going to stop this video, and in our next video for this section, we will start working out problems.